Given triangle ABC and a point P on one of its sides, call line L the splitting line of triangle ABC through P if L passes through P and divides triangle ABC into two polygons of equal perimeter. Let triangle ABC be a triangle where BC equals 219 and AB and AC are positive integers. Let M and N be the midpoints of AB and AC, respectively, and suppose that the splitting lines of triangle ABC through M and N intersect at 30 degrees. Find the perimeter of triangle ABC. In researching the splitting line for the midpoint M, we notice that one polygon is a triangle, the other one is a quadrilateral. Because the perimeters are equal and MK is shared, the actual equality boils down to the equality of BK to KC plus CA. We can draw a circle to transport CA to CX. If MK is the splitting line, then BK is equal to KX, so that BK equals KC plus CA. Since KX equals BK, K turns out to be the midpoint of BX. That's very convenient, because then MK becomes parallel to AX and the indicated green angles are congruent. Let's draw a line parallel to AX through C. The yellow angle plus green angle next to it is equal to the sum of two green angles because it is the exterior angle for angles A and C in the triangle AXC. So the yellow angle is actually a green one and CP is the bisector of angle C. So the main finding is that the splitting line MK is parallel to the bisector of the angle C. Now let's move on to the second piece of information given in the problem, the angle between the two splitting lines through the midpoints. In this figure, yellow segments are the splitting lines through the midpoints M and N. The yellow angle is given to be 30 degrees. We note that it is an exterior angle and equals to sum of blue and green angles. Since bisectors are parallel to the splitting lines through the midpoints, twice the yellow angle equals to the sum of angle B and angle C. Finally, we find that angle A is actually a great angle to work with, 120 degrees. We can now use cosine theorem to relate the side lengths to each other and take known length of BC, which is 219. Therefore we arrive at a quadratic equation for B and C values. We need to solve this equation for integer values. Let's start factorizing 219. The 3 among the factors makes us to investigate the divisibility of the right side by 3. Since the expression is symmetric, we have 6 cases to consider. Among them, 2 cases result in an integer divisible by 3, either x and y are both multiples of 3 or they are both equivalent to 1 in mod 3. Let's put the latter case in the context of modulo 9 since the right side is divisible by 9 as well. Apparently, the right side is non-zero in modulo 9 for all possibilities when x and y are equivalent to 1 in mod 3. This means x and y must are both divisible by 3. Let's simplify our equation a little bit using the newly defined variables. Let's define x and y for the sum and difference of m and n values. This gets us a few cases where we can do a case study for m values of 1, 2, and 4. If m is equal to 2, we can rewrite the earlier equations and arrive at an equation that involves one perfect square and one 3 times perfect square. That's the only way to satisfy the requirement. This equation may be satisfied if we have one perfect square and a 3 times perfect square on the right side as factors of q and r, since q and r has no common divisor. In this case, there is a solution for the q and r, where capital Q is 3r squared and r is q squared. Note that lowercase and uppercase variables do not necessarily correspond to the same letter. They are just there to indicate that one of them is a perfect square and the other one is 3 times a perfect square. Which one is which is not known in advance. With the q and r values at hand, we can reverse the equations to find x and y and eventually b and c. Let's do the algebra for x. We arrive at the solution. We shall still try one more case. This case is similar to the previous one. The factor of 4 is now embedded in the q and r values. We find same x and y values as expected. Computations are very similar as well. As expected, we arrive at the same side lengths and the perimeter for m equals 1.